Karl's MJB3 mask aligner, currently set up for 3-inch wafers. The chuck is suitable for HP mode and standard mode operations, and this is the table where the substrate holder is loaded, and there's a notch under the chuck, and the gasket has to be in place in order to operate in high precision mode. So the wafer, we should load it such that it is approximately in the center of the chuck, and then insert the table, and this lever here has to be rotated counterclockwise so that the wafer will come in contact with the mask. And once the vapor is in contact with the mask, use the separation lever to lower the substrate, and once there is a separation between the substrate and the mask, these alignment knobs can be used for moving the substrate with respect to the mask. I'm going to load every time we are going to unload a wafer, the separation lever should be pressed forward to contact mode, and then lower the chuck. I'm going to load a wafer with some pattern on it so that we can see the image on the video monitor. So now we have an image because it's a pattern wafer. I'm able to move once we see the pattern, we can adjust the focus knob on the microscope tower to focus the image. And to locate the alignment marks, we have to use the manipulator. I'd say the microscope has 3 objectives for higher magnification. So this is 5x. And this is 10x. This is 20x magnification. The CCD camera detects the image and it is connected to the monitor. There is a power supply for the monitor and a separate power supply for the camera. The image can also be viewed through the microscope. Once the alignment marks are properly aligned using the x-axis, y-axis and the theta knobs. Now push the lever to the contact mode, and I have selected here standard mode with soft contact option, and I press the expose button. The lamp housing will move forward and the shutter will open, and once the timer is up, the lamp housing will move backwards. I'm going to select the HP mode. In HP mode, we can the standard high precision mode, or we can also use the vacuum chamber. When we select the HP mode and vacuum chamber option, there is a vacuum generated between the substrate and the mask, and it gives a high precision contact. The vacuum is adjustable with this needle valve here. We can increase or decrease it. The maximum attainable vacuum level is minus 0.6 bar, or about negative 17 inches of mercury. So you can adjust the timer here by the outer knob is for selecting seconds or tenths of seconds, minutes, tenths of minutes, hours and tenths of hours. And the dial is adjustable. The time is adjustable by the inner dial. You can set whatever duration is desired. Now pressing expose button will start the exposure operation. Now once the exposure is over, lower the chuck and then push the cable out, pull it out and replace the wafer. The system will be shipped with the microscope disconnected and the camera assembly and its associated parts will be disconnected, and also the lamp power supply will be also disconnected to the system. Now I'm going to discuss more about the lamp power supply. So I selected minutes mode operation so that I can leave the shutter open in order to demonstrate how the constant intensity mode operation of the power supply works. Now right now the shutter is open and the CP mode operation is constant power mode, and you press the DS button to momentarily display the detector output. The detector is inside the lamp housing and it is showing 25.7 milliwatts per centimeter square. Now this will be at 400 nanometers, and if we press DS again, there is a CI2 which could be the second detector in the same location. That's the 365 nanometer. The intensity level is showing about 18.7, but there is no wavelength filter in the line. So the intensities can be selected depending on the desired energy levels, and we can say now the intensity level can be adjusted So once we do that in constant intensity mode, now the lamp power supply is operating in order to maintain the intensity level at 17.4 milliwatts, and the actual power going to the lamp is 290 watts. So likewise, both the CI1, constant intensity 1, and constant intensity 2 can be adjusted. After calibrating the detector readout here using an external meter. So the external meter, a calibrated external meter is needed in order to set up the constant intensity modes. So we have to use the external detector in the exposure plane and adjust the potentiometers here under the CI1 and CI2 indicators to match the reading on the external meter. Procedure for operating the power supply is available, and the lamp power supply has to be plugged in and powered up before powering up the machine. So when the system power is off, by pressing the start button, the lamp can be ignited. The lamp housing in this system is purged with dry nitrogen, and I'm using a 25 psi dry nitrogen to the system, and there is a flow meter here. Unless the flow is about 4 to 5 SLPM, there is a flow switch in line with the nitrogen purge, and without this much flow, the flow switch is enabled, and the flow switch enables the lamp to start. So if there is not adequate flow, the power supply will indicate N2 loss. There are adjustment knobs on the lamp housing for x-axis and y-axis adjustments here, and z-axis. The lamp housing is self heat dissipating, and nitrogen is used to purge the housing. And the microscope needs its own illuminator. The illuminator power supply is a standalone DC source, and there is a yellow filter in line with the lamp so that it will prevent the pre-exposure of the photoresist from the sample. In order to load the mask on the mask holder frame, slide the mask holder should be tilted upside down, and there's a vacuum groove here. Locate the mask evenly around the 3-inch opening, and turn mask vacuum on by pressing the button. And now the mask is held under vacuum. So once the mask is held under vacuum, slide the mask holder in its groove and tighten the knobs in the front. There is a substrate holder Z-axis potentiometer here. This knob will mechanically move the substrate chuck up when rotated counterclockwise and down when rotated clockwise. So in order to compensate the gap or different, in order to compensate various thicknesses of the substrates and mass, this knob has to be used. The microscope manipulator and the table, the XY table. Now there are two buttons on the arm. The lower one enables the X-axis motion, and the upper button, when pressed, it disables the brake and then enables it to move in Y-axis. Now these are pneumatic brakes, and these switches are connected to the solenoid valves, which turn on, which are normally open, and the brakes are engaged. The stage cannot be moved unless these two buttons are pressed. I'm loading the sample and then raising the chuck, and then I'm going to, when I separate the substrate from the mask, the separate light turns on, and then when we push it to the contact position, the contact lights turn on. Only when the contact light is on, the exposure can be enabled. As soon as the exposure button is pressed, the microscope will be lifted up, and there is a limit switch here, and after that the lamp housing will start moving forward. Manometer box here indicates the compressed air pressure as 4 bar, which is adjustable by this regulator here, and this is output from this regulator, which is 2 to 3 bar, which goes to the check locking mechanism, and this is 1 bar nitrogen, which can be adjusted from here, and there is a vacuum gauge here. This toggle switch is to turn off and turn on nitrogen. When the system is not used, you can turn off the nitrogen from here. And the purge here is connected to the purge line to purge the mask, and the purge flow can be adjusted. This toggle switch is for the compressed air. The lamp housing, UV shields are magnetically attached on the housing. In order to access the lamp, we have to unscrew this hex nut here, and then the lamp housing can be tilted like this, but make sure there's a nitrogen line here which is to be disconnected before tilting the lamp, otherwise the line may get damaged. So once you disconnect it, we can tilt the lamp head like this, and now we can access the lamp. The lamp is to be installed in anode down position. The anode is marked on the lamp, which is a USH 350DS Ushio UV lamp. And this is the ellipsoidal reflector, which is a brand new one here, and the dichroic reflector. And the heat sink here down under the reflector is purged with air. This is the optical housing, where there is a collimating lens and integrating lens assembly here. Now there is a final condensing lens at the end of the lamp housing, which is right here. Now this will be shipped, removed from this slot here, which is to be installed at the time of installing the machine. The system will be shipped with all the moving, the microscope assembly table, everything secured so that no parts will move during the shipment. The lamp will be removed from the lamp housing and will be packed separately. And the braided wire is the anode for this unit. So we remove the nut, and then the braided wire will be hanging here. So after screwing in the lamp, the cathode into the head, insert the braided wire on the electrode and make the connection. This is the anode. This is a working lamp, relatively used for a very short period. Connect the anode lead and then tighten the thumb screw gently. And then in order to close the door, the screw end has to be aligned with the threaded holder and then lock it down. Make sure the housing is properly aligned. These are the needle valves for adjusting the mirror house movement, for reducing or increasing the forward motion, use this knob, and for reverse motion, adjust this. Right now, these are adjusted for 4 bar compressed air pressure, and this is the airing knob which turns on air in HP mode. So this needle valve has to be optimally adjusted, and the microscope down speed can be adjusted using this knob, and the hard contact vacuum level can be adjusted using this, as well as the knob right adjacent to the vacuum gauge on the front panel of the machine, which is this one. So this knob gives a better adjustment of the contact vacuum level in this gauge.